Okay, good morning. We are live and about to embark on 7.5, uh, section 7.5 in intermediate algebra. So let's start with our first example of the relatively basic one. So going along the lines that we've been doing in class in our winter 17 class, I want to make these denominators the same, and then we'll add them up and solve for x. So in other words here, so I got 2, 3, 6 as my denominators, so I wanted to make every denominator 6. So the first one here, I'm going to multiply this by 3. If I multiply the denominator by 3, I have to multiply the numerator by 3. Okay, so that's 3 times 2 is 6. The middle term here, I'm going to multiply this 8/3 by 2 over 2. I'll mess up my equal sign there. Alright, so that'll get me 6, and this 6 is already 6, so I can leave that alone. So now when I go to solve this, I can just use the numerators, and that's going to be 3 times x, which is 3x, plus 8 times 2, which is 16. That equals 1. And now my equation is this nice little thing, and I can solve for x by subtracting 16. That gives me 3x equals negative 15. Careful on your addition there of a negative number. And then that will lead me to say that x equals negative 5. Okay, so x equals negative 5. There are no x's in the denominator for me to have to check that to make sure I don't get an undefined expression. So we are done with that problem. Okay, example 2 is as such, and notice this is a little bit different because I'm dealing with these binomials here in my numerator. So I always like to put them in parentheses. That helps me to remember to do the distributive property, or I don't know, just helps me out in general. So let's see, looking at the denominators, I got a 2, 9, and 18, so it looks like I want to change all these denominators into 18. So therefore, starting with t minus 4 over 2, I've got to multiply the 2 by 9, and what I do to the denominator, I have to do to the numerator. So I got 9 over 9. This 9, I'm going to multiply by 2. So what I do to the denominator, I have to do to the numerator, so it's 2 over 2. And the 18 I'll just leave alone. So again, my denominators are the same. I can just use my numerators to solve for t in this case. And now I'm going to distribute, use the distributive property. I'll do this down here. That's going to be 9t minus 36. What do I got here? Negative 2 times t, which is negative 2t. And that's going to be plus 6. That's going to equal 5. And there we are again. We got a nice equation to solve for t. So I'll combine my like terms, and what have I got? 9t minus 2t. That's these two like terms only. That gives me 7t. And then how about the negative 36 plus 6, which is negative 30. That equals 5. Okay, add 30 to both sides. 7t equals 35. Divide both sides by 7, and t is going to end up giving me 5. Okay, again, I don't have any x's in any of our denominators in this original expression, so therefore I don't have to worry about the undefined expression coming about. Okay, onward and upward to example 3. Okay, here it is. And now, looking at this one, this looks a little different now. I see this x here, but I don't see x's anywhere else, so it's kind of like we can, if you feel better, putting denominators here so we can get them to be the same. I can put these over 1, which is just a little helpful. And now it seems to me a little easier to say, let's see, I've got to get all the denominators to equal x, since that's the LCD. So I'm going to multiply this 3 over 1 by x over x. Second term already has the x. How about this third term here? This is going to be x over x, because I want that denominator to be x, and same with the 8. Multiply it x over x. Okay, my denominator is now the same, so we can combine our numerators. Again, let's do it down here. Remember, I know I'm multiplying, so I get a little lackadaisical with my details here, but I realize in my head what I'm doing, that I'm multiplying these numerators together. So this is x times 3, which is 3x, minus 6 equals, what's x times x here? X squared plus 8x. Okay, as soon as I wrote down x squared, now that tells me I'm going to have a quadratic equation, and in my head I'm thinking I'm going to have to get this equation equal to 0, which I'll do right now because this is where we're at. X squared is positive here on the right side, so I'm going to leave it there instead of bringing everything over to the left and the 0 to the right. So I'm just going to leave it here, and I'm going to subtract 3x first of all. Subtract 3x. And at this point here, it's going to give me, let's see, bring down the negative 6. That equals x squared plus 5x. Okay, and then finally I'm going to add 6 to both sides. Add 6. So I know here's my 0, that equals this x squared plus 5x plus 6. I could rewrite it if you want, or, well, I guess I will. X squared plus 5x plus 6. And I've got to factor this now to answer this question, or to solve for x. Alright, so that means what? I'm going to, it's the easy one, so I'll set my parentheses up, like so, and fill it in. X plus, now I've got 6 is my number, I'll do it up here. I need 2 factors of 6 that add up to be 5. So 3 and 2. 3 plus 2 is 5. 3 here, 2 here, equals 0. So that means when x equals negative 3. Okay, we are progressing to example 4. A little bit more involved here with this problem, because now we've got same process if we're getting the denominators to be the same. What we have to do here is we have to factor whatever we can out here. So this trinomial here looks familiar, so we're going to factor that first. Okay, so let's do so. How we've been doing in class. Lead coefficient is 1, so that's the easy one. So let's fill it up. I've got plus, and this would be minus, and I need 2 numbers that'll subtract, 2 factors of 30 that'll subtract to give me 1 in the middle. So that looks like it's going to be 6 and 5. Okay, 6 times 5 is 30, and 6 minus 5 is 1. So I'll put the 6 first, then the 5. Okay, so now we've got that factored. I can get this out of our way here a little bit. And now I can figure out what the what I need to do to get the denominators to be the same. So it looks like the LCD is the x plus 6 times x minus 5. So on this x minus 5, I'm going to multiply top and bottom by the x plus 6, because that's what's missing. Okay. And then this third term here, I'm going to multiply top and bottom by x minus 5. X minus 5 over x minus 5. How's that? Alright, so now we know the denominators are the same process. I don't have to figure that in my solving for the variable x. I just want to lay out my equation now. So again, I'm going to take this down below here. So I'm going to have 4x, and that's going to be plus, let's see, distributive property here, 2 times x and then 2 times 6. So I got 2 times x is 2x, plus 2 times 6 is 12. And that's all going to equal this 1 times x minus 5 is just x minus 5. Okay, and again, here's our equation. Combine my like terms. 4x and 2x is 6x plus 12. That equals this x minus 5. And I'll subtract x from both sides. And what have I got? 5x plus 12. That equals negative 5. Okay, running out of room here. Subtract 12 from both sides. I guess I can go up a little bit. Subtract 12 from both sides. I've got 5x, that equals negative 17. And then let's divide by 5 to get the x by itself. So x equals negative 17 over 5. Alright, this is my answer, my potential answer. And then we want to check that if I put negative 17 over 5 in the denominator here anywhere, will that, either this one or this one really, will that make it a 0 in the denominator? And the answer to that is no. If you have negative 17 over 5 plus 6, that isn't going to get you a 0. It would be a number, but I don't care what number it is. Just that the fact that it's not 0, which would make that undefined. So negative 17 over 5 is the answer to that problem. Okay, continuing on with example 5. Just another one. After a while, I hope you feel the same way. It is kind of gets a little redundant, but in a problem like this, it's clear that I have 3 terms in the problem. X minus 4 is in the denominator of 2 of them, so I've got to put x minus 4 in this last term here. X minus 4 bottom and x minus 4 on top. We know there's a 1, it's 1 over 1, so you can go ahead and put that there if that helps you. Essentially, my denominator is x minus 4. I'm solving for this problem, so I'm taking the numerator, which is 2x. That's going to equal, what, 8 plus 1 times x minus 4 is just x minus 4. And then I'm going to solve now for x. So let's see, I've got 2x equals 8 minus 4 is 4. So let's see, what should I do here? 4 plus x already. And I see I got x's on both sides of the equal sign. I've got to get them all over onto one side. So I'm going to subtract this x and bring it over to the left side. So that's what I got. 2x minus x is 1x that's going to equal 4. So my solution is that x equals 4. However, when I substitute 4 for the x in the equations in these denominators, what happens? They become undefined. It becomes 8 over 0. So that means x is not a solution. My solution for this problem would be none. There isn't a solution for it. Okay, that's the case where the answer made the denominator, any one of the denominators, 0. So therefore, it is undefined and it is not a solution. If I had a second number to pick in there, to put in there, then that would be the solution. I just have one solution. Okay. 2 more examples to go. And here I've got x minus 2, so I can put this term here over 1 and this 1 over 1 as a way of filling in that denominator and being a little clearer, saying that I need x minus 2's in these positions here. That way I'll have x minus 2's all the way across. So let's go. I've got x minus 2, top and bottom. Okay, and over here, same thing, x minus 2 over x minus 2. Good. Alright, so let's go and simplify this numerator. So I'm going to have x squared minus 2x. That's the distributive property, right? I'm going a little backwards here, but that's the way I laid it out, and that's the way it can be. Then it's going to be plus 14. That equals 7x plus, well, 1 times x minus 2 is x minus 2. There we go. And solve for x. Now this is x squared. This tells me it's a quadratic equation, so I'm going to bring everything from the right side over to the left. Alright, so here this tells me I've got 8x, combining my like terms. So how about I subtract this 8x from both sides? Okay. How about x squared minus 10x plus 14? That's going to equal this negative 2. Then let's add the 2 back to both sides. And I've got the familiar x squared minus 10x plus 16. That equals 0. Scooch that up a little bit. Okay, so factoring the trinomial, because I'm solving for x, looks like I'm going to have 2 answers. Let's see, help me out with this. X and x. What sign goes here? That's right, whatever sign this is, I just copy it. Now I determine what this sign is based on what sign this and this is. So which means a negative times what is a positive. That means a negative times a negative is a positive. Okay, so that checks out. Then what are my 2 numbers for 16? List all my factors of 16. That'll add up to be 10, negative 10 at that. Looks like 8 and 2. Both negative. So I got 8 and 2. So therefore, my solutions are x equals 8 or x equals 2. However, when I look at the denominators, where am I here? When I look at the denominators, I see the denominator is x minus 2. So therefore, 2 cannot be the answer. That'll make it 0 in the denominator. So my solution is x equals 8. I only have one solution. Okay, so there's the example of what happens when you have one that works and the other does not work. So just eliminate it. Alright, our last example is example 7, where we have to solve equations for a specified variable. Okay, and here's one that's our example. And I did this in class, and I solved for x, if you recall. But this time I'm going to just change it up, and I'm going to say let's solve for b, the one in the middle, just for the heck of it. Solve for b. So essentially that means I want to get b by itself. Alright, the process is the same. I've got to multiply everything by the LCD or get all the denominators to be the same. So here I've got an a. What's missing is the b and the x, so I'm going to put bx here and multiply top and bottom by that bx. And the b then is missing the ax. ax over ax. And finally x is missing the ab. And now they all have abx as your denominator. Now I can focus on the numerators of simplifying them. So it looks like I'm going to have bx times 1 is bx plus ax times 1 is ax. That equals 1 times ab is ab. Alright, we are solving for b now this time. And so notice I have a b over here on the right and a b on the left of the equal sign. I want to get those together. So essentially what I can do is I can subtract, and that's what I want to do. I want to subtract AB. They come together and they're going to be over here, and I'll just throw it over here because there isn't a like one there to share with. Okay, and what have I got then? Let's see, I'm going to have bx minus ab plus ax equals 0. Okay, that's alright. But now I want to get rid of the ax over here because it doesn't have a b. So that means I'm going to subtract ax from both sides. Okay. Scoot it down. Now I'm going to have bx minus ab, that's 0, equals negative ax. Okay? Now here's the key part of this all. I've got a b here and a b here, which means it's the GCF. I want to factor out the GCF, which is b. And if I factor out b, then what's left over is x minus a. And that's equal to negative ax. And now to get b by itself, I'm just going to divide both sides by x minus a. Okay, so b now equals this. Okay, that's it for 7.5. See you at 7.6.